Right, let's look at question 1.4. The effect of gentle heat on malic acid is shown below. So this must be malic acid, and this must be what's made along with water. So it's a condensation reaction. A reaction that releases water is a condensation reaction, and we say that the malic acid has had water removed or it's been dehydrated. The student predicted that the yield of the reaction, so making this, would be greater than 80%. Okay, in an experiment, 10 grams of malic acid were heated and 6.53 grams of the product were obtained. So I know where I'm going straight away with this. Why would I be given grams? The only reason I'd be given grams is to use this formula I've given to work out MR, and moles is number of grams divided by MR. So let's work out the MR of this, use the number of grams and work out the number of moles of this. Moles is always a useful value to have. So now, if I look at the malic acid here, I've got two O's bonded as OH's here. There's no carbon on that corner. There's a carbon there, a carbon there, a carbon there, and a carbon there. There's 4 carbons on those corners, but these are just OH's. There's no carbon on that OH. So I've got 2 OH groups. I've got 1, 2, 3, 4 carbons and 2 O's either side. Now I've just got to check that every carbon, each of this carbon here, this one here, this one here, and this one here have actually got 4 bonds, because every carbon needs 4 bonds. That's got 4 bonds, a double and a single and a single, a double, a single and a single, that's okay. But these 2 carbons have only actually got 3 bonds. So why have they only got 3 bonds? Well, there's an H on there that's not seen. So on a skeletal formula, you don't draw H's. So I know that there's an H there, and this one's got this carbon here has got 3 bonds, there's an H there. So if I count up the number of H's, I've actually got 1, 2, 3, 4, 2 hidden H's there. I've got 4 O's and I've got 1, 2, 3, 4 carbons. If I do the MR, 4 times 12 for the carbons, 4 times 16 for the O's, and 4 times 1 for the H's will come out at 116. To work out number of moles, well, moles is mass divided by MR, so the moles of malic acid is 10 divided by 116, which comes out as 8.62 times 10 to the minus 2. What does that tell me? Well, I've got a reaction here. I've got no number in front of this, so I've got a 1. I've got no number in front of this, I've got a 1. And I've got no number in front of this, I've got a 1. It tells me that 1 mole of this makes 1 mole of this and 1 mole of this. Or 10 moles of this would make 10 and 10. Or 100 would make 100 and 100. I've got equal numbers of moles of this making equal numbers of moles of this. So I know my number of moles of this product is 8.62 times 10 to the minus 2. If it works out perfectly. So in a perfect world, if I get 100% of this, I'm going to get the same number of moles that I have of this. I'm going to get 8.62 times 10 to the minus 2. It probably won't work out that way, because in an experiment you never make 100% of something, you lose something along the way. But let's use 8.62 times 10 to the minus 2 moles of this, if I make 100% of it, and let's use its MR to work out the mass of this that I could have made. So 8.62 times 10 to the minus 2 moles of this, let's work out its MR. Well, let's see how many carbons I've got. I've got 1 there, I've got 1 there, I've got 1 there, and I've got 1 there. I've got 4 carbons, 3 O's. This carbon's got 4 bonds, that's okay. This carbon's got 4 bonds, that's okay. This carbon has actually only got 3 bonds, and so has this one. You know what? There's 2 H's again on the top of there, unseen, to make the 4th bond. So I've got 3 16s, 3 O's. I've got 1, 2, 3, 4 carbons at 12, mass 12 each, and I've got 2 H's, mass 1. So what I've got is, I have got a mass, an MR of 98. Now, moles is mass divided by MR, so moles times MR will give me the mass. Number of moles of this, 8.62 times 10 to the minus 2, multiplied by 98, which is the MR, tells me that I should make 8.45 grams if I get 100% yield, if everything works out perfectly. It's no surprise that I've got 6.53 grams. I've lost some along the way. Well, how do I work out the yield? That's what I should have made. That's what I did make. I divide the smaller one by the larger one, so 6.53 divided by 8.45 will give me a fraction, and I multiply it by 100 to get the percentage. So my percentage yield is 100 times the smaller number, what I actually did get the mass of the organic product that I made, divided by the mass of what I should have made, and it works out as 77.294. Now, let's actually look. I have got three numbers there, three significant figures, and three significant figures here. I count the O, the zeros, if they're to the right of other figures. So I've got 1, 2, 3. I've got to count those two because they're to the right of the 1 in my significant figures. Three significant figures there, three significant figures there. I've actually got 1, 2, 3, 4, 5 significant figures there. It can't be more accurate than the initial values that I'm given. I need to turn that into three significant figures. I need to round it up. 77.294 rounds up to 77.3, three significant figures. That is actually less than 80%, so the student was wrong.